Welcome once again. Now, here's a picture of the engine. The four strokes of an engine, how it works. We're going to go through it from pictorials, which is more visual to understand. Four parts of it. The parts of inside the cylinder. Now, this is the piston. We refer to this part as the piston. This is the part called the crankshaft. This turns and rotates on this crankshaft, this piston that you've heard about. The other parts of it is called the valve. A valve opens and closes. Another valve, exhaust valve, opens and closes. The part over here where this goes down and up and combustion or burning takes place is called the combustion chamber. Here we have the spark plug. We always heard the expression in automotive, you need air, fuel, spark, and compression. What does it mean? Well, let's go through details. We just said this is a valve. This is called the intake valve. This is called the crankshaft. Something called the journal. But anyway, the camshaft over here is up here, pushing down and on these things, which is out of the picture, pushing down on this valve and pushing down on this valve by something called its lobes. Anyway, that's the part that's not visible over here. So just think of it, something is pushing it down, something is letting it go back up. You see this dotted line over here? That represents when this is closed and when this is open, the position. As you see, when this is considered closed, look at the one that's closed, look at the one that's open. You see this valve is seated right here, seated over here, closed position. You see, it doesn't let anything in from here to here. As soon as this opens by the camshaft pushing it down, see the area over here, the space is open. This is when it's closed. You see the dotted line? And this is when it gets pushed down by the camshaft. When it gets pushed down, you're going from here to here on this to push this down. So it was seated over here at the corners over here, and then it got pushes down. And what does that do? Remember we just said, in any engine, air, fuel, and spark. Let's begin with air and fuel. Air is being sucked in over here. This piston is going down. It was up here. It's going down. See the arrow? As demanded by this. This rotation, it's called a rotation, is not from up and down or vertical. It's going like this, like this, like this, like this, like this, in a circular motion. This circular motion brings this down. This is called the intake stroke. Why? Called the intake valve. Why? We have to let air and fuel into this combustion chamber where we will ignite it to create an explosion, to make this piston go down. That's called creating work. Now, air comes in. How does air come in? Remember, you're on the pedal, the gas pedal. It's called the gas pedal, but you're actually letting in air. Isn't that amazing? You're letting air in, right? This creates a vacuum. When this goes down, it creates a vacuum. You're sucking in air. You're opening up something called the throttle body, which is not in this also. The plate in the throttle body. Doesn't matter. We went over it before. There's other videos to look at. But fuel comes in from where? The fuel injectors. Fuel injectors open and close. Think of them also as valves. A valve is something that opens and closes, like a switch in electronic that opens and closes. When this is open, the air comes in, you're pressing the pedal. If you're cruising, if you're driving, if you're in idle, something called the idle air control valve is letting the air in. But let's say you're cruising on the highway. The fuel goes in by the fuel injectors. Who controls that? The computer controls that by giving it a ground. The more air, the more fuel. The less air, the less fuel. So the computer controls how long the fuel injector will be on and off, thus creating in this combustion chamber more air fuel mixture or less. Once this is open, air and fuel come together. The fuel injector is behind this and it comes in like this. Okay, this system over here. Now what happens? This piston is going down to something called bottom dead center. When you'll see in the other example, eventually this closes. And you know what happens when it closes? Let's go to the other example. Look at the difference. This is closed against this. This is wide open. Now what happens? No more air fuel. That's it. You're off the accelerator pedal. That's it. Now what happens? We get as much as air and fuel squeeze into this chamber as much as we can. Why? That will increase the pressure. That will increase the temperature. Then he comes back up. He was down. Something called bottom dead center, where it goes all the way to the bottom. Then because of this rotary rotation, it has to swing back up. When he swings back up, guess what happens? This is closed. The air and the fuel already is in here. Now he's going to squeeze it. Calling compress. When you compress something, compression ratio, right? You heard that? Compression ratio? That's what you're doing. You're compressing that air-fuel mixture to get it, to squeeze as much as you can into that small area, to put more pressure, more temperature, to get better combustion. The more, the better. Now, when you come up to top dead center, you are over here, bottom dead center. Now you're swinging it, and you're going all the way up to top dead center. Before you come, let's go over here. When you were over here, when you come back up here, guess what? Now we have the air, we have the fuel, it's hot. It can reach about 1,500 to 2,000 degrees in there. That's as hot as it gets. We only need a little. Guess what happens then? The computer says, okay, fine. Spark time. It's time to spark. It's like lighting a match in this combustion chamber, which are temperatures high already and pressures are high already. We want that. Why? It'll force that piston down. So when this is closed, look again, compare. First, the air fuel has to come in. Then we have to squeeze them together we let them go as we try to get as much air fuel into this area as we can. That's why this piston is going down. When this goes down, the volume of the space increases. You can put in more air and more fuel. This is going down from here to here to here. More area means more air, more fuel. That's great. That means more compression and a better spark, more ignition, more combustion. We want that. Again, now it closed. Now we're compressing it. We compress it. Oh, that's great. The pressure, temperature, everything goes up. The piston head, compresses it, squeezes it. When that happens, boom, spark comes in. Who controls the spark? We said fuel injectors controlled by the computer. Who controls the spark? You control air. The computer controls the fuel injector. Who controls the spark? You? No. The computer again. PCM. See, this is the components are the same, but who controls it is different. The computer decides when to give you spark. When you go bottom dead center, when you go bottom dead center over here, when you go up here, the spark comes in, you squeezed it as much as you can at air fuel ratio, you're coming up. That spark comes in, the ignition control module. Remember we went over it before? There's so many videos I made about that. Ignition control module, ignition coil, that gives the spark. There's a transistor in there, we spoke about that takes the transistor, which goes to ignition coil, called a transformer, cuts it on and off a collapsing field, and then creates a spark. That spark comes in here. Where does it go to? Through the spark plug wires. Goes over here, right over here in the cylinder. And then when that happens, now the piston is on the downstroke. It goes down. That great, tremendous force pushes it down on the piston head. Now what do? We use this to create the crankshaft, to create horsepower, to create torque. That we'll talk about in a minute. We need torque. We need horsepower. So we have to go over it again because it's very difficult to understand. We first need air and fuel. Fine. This is open. Oh, excuse me. A little dry today. But anyway, air fuel comes in. This is on its way down, letting as much as it can into this area by going down. When that happens, that's it. We say that's enough. Close the gate, close the door, close the valve. That's enough. We have enough air fuel in here. We got to compress it. We compress it. Everything increases, pressure and temperature increases. Now what happens? Fine. Now they're both closed. Now we give it a match. We give it a fire, a spark. Boom! It pushes it down. Once it pushes it down, what happens? It has to go back up. And when that happens, now compare. We were here in the beginning. This one was open. This is open, right? When this is on its way down, when this goes up, this air fuel ratio that was compressed at high temperatures, high pressure, this pushes it out because when it went down, that's it. It created horsepower. It created the horsepower, the torque that's needed to move the wheels. That we'll talk about, like I said, in a minute. It did its job. We got to force what's not needed now, the exhaust, the byproducts of it, out of the engine, out of the cylinder. In order to do that, guess what? We need an exhaust valve. The exhaust valve opens. You see, it's off its seat. It opens. This is closed. Compare. This is open. See? What happens? We need a way to push it out. It came in through here. We got to push it out through here, right? So whatever was burned. Whatever wasn't burned, we have to push it out. Then you have an exhaust manifold, obviously not in this picture. Hold on. Obviously not in this picture. An exhaust valve goes to the exhaust manifold, which is very hot, obviously. And that's what the oxygen sensors are. So we go over here, we push it out, and that's when you try to get the correct air-fuel ratio by more fuel, less fuel coming into here. The computer controls it. The byproducts, I call this the input. To make it more simpler, this is the input, this is the output. By looking at the output, we can see what the input was, if this is easier to understand. We know how much air fuel was in here. We know how much to correct when it goes out. Maybe there was too much fuel. Maybe there was less fuel. Maybe it's too much air, less air, whatever. Oxygen sensors are here on the exhaust manifold, measuring how much oxygen is in the air-fuel mixture, in the air. Then the computer decides, okay, you know what? More fuel. Open up the fuel injectors longer, less fuel. Let's say it's cold. We need the fuel injectors on a cold winter day in January. We need those fuel injectors open. Wide open, right? Then in the summertime, when you crank that engine, it's hot already. We don't need that fuel injector on that long. We close it. Now we push everything out. Now, I hope you understand this because this is tricky. Like I said, there's many things you could learn. You learn under the car. But you cannot see the strokes inside the car of an engine. I don't care if you take it apart. Obviously, the car has to be working, right? On, right? You're not going to see this. Some things you have to learn from a textbook. You have to learn things from a textbook. Anyway, as you see, came in here. We squeezed them together. The spark then came, pushed it down to create the work, the power that we need. Translate it into horsepower and torque. Then whatever we don't need, we get the leftovers, the remaining, we push it out. Okay? I hope that was a little informative. All right. Now, when does it do it? When does air fuel? All set by sensors. All the sensors we were talking about in the beginning. How long to keep the fuel injector? How much fuel? The sensors. That tells it how much fuel to put in. That's not in this picture. Now, the other thing about, and I wanted to show you. Now, top dead center, bottom dead center. Remember we spoke about that. This is as much as it goes to compress the air-fuel ratio. We saw the piston go up, 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 up. That's it. It doesn't go all the way up. There's a little area over here before it gets to top dead center, actually. This is all the way when it goes down. You see when it went down, right? And we said it goes down, down, down. Well, it bottoms out, but there's a limit to how much you can bottom it down to. This, compared to this, the ratio gives you something called the compression ratio. So someone talks about your engine. Now you understand what the compression ratio is. It's when the piston it bottoms down and it goes up to the top. The more the compression ratio, the more goes down and up, the better the compression ratio. The better horsepower, the better torque. Now, there's a relationship between horsepower and torque. Torque is a twisting force. Let's look at the graph. When you create horsepower, you create torque by the crankshaft turning, correct? We need torque. When you're in first gear, second gear, you need torque to move the wheels more because they're stationary. It's harder to move those wheels when you're parked. Once you get going in that car, the wheels start turning, you need less torque. You need more speed. So therefore, you're cruising. I always give this example. Me and you are pushing a table. That table is stationary. When we start to push it, we say, oh boy, it's hard. You have a lot of resistance, don't you? It's hard to push it. But what happens later? When we start moving the table, we need less force because we have less resistance. It's starting to go and go. So much with the car. The car, once it's parked, that's the hardest thing for the car. Once it's cruising, that's it. It's easier. We need speed. Look at the graph. When you talk about horsepower, how much horsepower you have, how much torque you have, right? Torque at the wheels and all these things, whatever, right? There's a certain amount where the torque will bottom out. The horsepower will increase. Look at this. This is RPM. This is RPM over here. Let's say this is about 2,500, in between 3,000, 2,500. Over here, engine RPM. The torque increased, look. Engine goes up. Engine horsepower goes up to about, 2,700. Torque goes up over here in foot-pounds over here, right? 80, whatever, 100, whatever, in between 100 and 20, whatever. Guess what? Look where it bottoms out. You're already at about 2,700 when the torque already starts bottoming out. So in the beginning, when you're starting to accelerate, torque goes up. You need that torque. But then eventually at cruising speed or 2,500, 2,700, you don't need that much torque. So the torque just bottoms out. The torque is not going to increase while the horsepower is increasing, 4,000, 5,000 with it. There's a bottoming out stage. That's what this is. And this is the point that they meet. So now you understand that, I have 400 foot-pounds of torque, whatever. It's at a certain horsepower. They can do it. Not going to go on forever. We don't need that much torque when you're cruising. I hope this was beneficial. Like I said, some things have to be taught from a textbook. I know you wanted the name of the textbook, or automotive technology. It's still hard to understand it unless you have proper teaching. I could not understand it by not going to school. In those days, we didn't have YouTube or things like that, obviously, 25 years ago. But anyway, if I take a medical book and I don't understand anything about medical, guess what? It's not going to help me. I'm not going to understand. I need proper training. This is hopefully where this channel comes in. Hopefully you understood. I hope you understood better what compression is, air-fuel ratio, and the compression stroke, power stroke, all these things. I hope you understood it better. And let me go once more again. This is called the intake stroke. I believe I left it out. This is called right over here. As you can see, the compression stroke. This is called the power stroke when it goes down from the spark. And this is called the exhaust stroke, where you just get rid of it. Whatever was left, the byproduct. Now, you see their fuel over here was over here. The fuel injector was over here. Now we have something called the GDI, a gas direct injection. We take that fuel injector, we put it over here. Better fuel mileage, better fuel economy, better pressure. So we went from here to here. But anyway, that's for a different subject. I hope this helped you. I hope this was more informative, seeing these pictorials. I'm going to continue in this direction. The views were much better for these things. I don't know why. I guess maybe understand it much clearer. I'm going to explain how the systems work because you cannot see these things from under the hood. You cannot see how an engine works. You cannot see how a heating system works, how the coolant flows. That's impossible, obviously. The best thing is pictorials. If you agree, please leave a comment. But anyway, Joe, Electronic Schematics for Auto, please. Actually, I need about 27 hours, which is about, I think about, 4,000 minutes, something like that. Actually 2,000 minutes. It's been a lot of support from the viewers. Thank you.